Okay, I'm Landon, and today I'm going to be showing you how to make a velocity measurement device for your SeaPerch underwater ROV. And so let's get started. Okay, so let's go over what materials we're going to need for this project. First thing you're going to need is this flow meter right here. It has 3 wires coming off of it, one for the power, one for the signal, one for the ground. You're going to need an Arduino microcontroller. This is an Arduino Uno that I'm using today. You'll need a breadboard, a USB-B to USB-A cable, some 3-conductor cable. You can use any type of cable. I've used an Ethernet cable in the past and stripped it. Today I just have this 3-conductor wire right here. You'll also need some wires to wire up your breadboard. 10K resistor, some liquid tape, any computer. I got my laptop here, and some wire strippers and 2 rubber bands. That should be everything you're going to need to build this today, so let's get building. So the first thing we're going to do is we're going to connect our flow meter to this 3-conductor wire so that we have some long wire so that we can put in the pool and it's connected to our computer far away. So we're just going to take the wire strippers, strip off a good amount from all the wires on your flow meter and also on your wire conductor, and then I'm just going to twist these wires together. And so give yourself plenty of length so that these aren't coming apart. If you have any type of ferrules to connect these wires, or some wire nuts, you can always use those as well. But I'm just going to connect these 2 wires by twisting them together, and then I'm going to use liquid tape to watertight that connection. To watertight the connections, we're going to use liquid tape. You can buy this at Lowe's or Home Depot. You pretty much just open it up and goop it on your connections. I've already put some on these before. I like to do 2 layers and give it about 5 minutes in between, 5 or 10 minutes to dry in between. Okay, so right now we're going to wire up the breadboard. We're just going to follow the schematic included. I'm not going to show all of that, but what we're going to do is just strip our wires and then plug them in the breadboard or the Arduino. Now that our Arduino and breadboard are wired up, all we do is plug our USB cord in to the Arduino and into the computer, and we're ready to begin programming the Arduino. To program our Arduino, now that we've connected it to the computer, we simply open up our Arduino editor that we downloaded. We open up the text file of the code that I've included in this tutorial. We copy all of the code, paste it into the Arduino editor, click the upload button, and it uploads to the Arduino. We're ready to go. Okay, now that we've got it hooked up to our computer, I'm just going to make sure that it's working, the program's working right. So I'm going to stick it under the sink to make sure we're getting some readings. So I'm just sticking in and out of the water. And as I move it in and out of the water, you can see that the output changes on the computer screen. This helps us to verify that the system has been built properly. To attach my flow meter to the SeaPerch, I'm going to demonstrate with this broomstick. First, I'm going to put 2 rubber bands around my flow meter. Then I'm going to place the PVC pipe of the SeaPerch in between the rubber bands and the flow meter. Wrap the rubber bands around and connect it to the other end. As you can see, securely attached. So now we've got it all finished and hooked up to our computer. We're trying it out here at the duck pond. So as I'm dragging it along, it's sending data back to the computer, and we can look at the velocity. And this is what the data looks like as it moves through the water. Hey, congratulations! You now have a working flow measurement device. Just hook this baby up to your SeaPerch, you can take it anywhere. For the rest of the video, I'm going to be talking about the design of this flow measurement device, the Hall sensor inside of this flow meter, the schematics of the breadboard, and also about the programming code for the Arduino. There are three main factors I took into consideration when choosing this particular design for my SeaPerch. The first factor being the cheapness of the entire project. The flow meter and the Arduino together cost about $40. On top of that, the only thing you have to pay for is some wire and a 10 ohm resistor. So overall, it's a pretty cheap project. The other factor I considered was the ease to build this. It may look complicated when looking at the breadboard, but by following the schematic, it's pretty simple and not that hard. The third factor was the ease of use of this Arduino. Just simply by installing the Arduino program on my computer, I can write a simple program, receive signals from the Arduino by a USB cable, and I can just see the display on my computer, see the results. And so, taking into consideration all three of these factors, I feel that this is the optimum design for the students that are building the SeaPerch. They need something that's cheap, easy to build, and something that's easy to use too. I'm going to use this diagram to explain how the Hall effect works. This is a diagram of the entire flow meter. This box right here represents the Hall sensor inside the flow meter. What the Hall sensor does is every time there is a change in magnetic field, it produces a change in voltage. So that's the main driving principle behind this whole flow meter. As water flows in this end, it's going to spin this fan. The fan has a small magnet on it. As it spins, it will pass by the Hall sensor, causing a change in the magnetic field. Every time this passes the Hall sensor and changes the magnetic field, the Hall sensor will send out a change in voltage, which can then be interpreted to the amount of water passing through this flow meter.
Okay, this is the schematic for our breadboard. The flow meter runs into the breadboard. The positive runs into 5 volts on the Arduino, negative runs into the ground, and the signal runs into the number 2 pin on our Arduino. This resistor helps boost the signal from our flow meter so that we can actually read it on our Arduino. Okay, this is our Arduino code. The main thing to look at is this loop right here, which counts the number of pulses per second going to the flow meter and also translates that into a flow of the velocity of meters per second. So it starts a function, this function right here, which counts how many pulses are passing through, does that for 1 second, stops the function, and then puts that variable, the number of pulses per second, through this calculation, which tells you how many meters per second you're traveling.